Welcome back, dear students. So today we will complete this first the topic we have taken, that was introduction to forming processes. So we will complete this one in this topic in this lecture. Now we will start from annealing, where we have stopped in the last lecture. So what is annealing? It is a combination of three different processes. Those are recovery, recrystallization, and grain growth. So grain growth I have already explained to you. Recovery is the process in which all the physical properties will be retained back without any change in the microstructure. So annealing relieves the stress, or I must mention here internal stress. You must write here internal. This is very important question asked many times in exams, like what does annealing do? So annealing releases the internal stresses due to cold forming. Those internal stresses are formed inside the material. So by heating you can relieve those stresses. So relieves the internal stresses in these three stages. Now what is the recovery phase? During recovery, physical properties of the cold working material are restored without any observable changes in microstructure. Now you can see in these pictures. So first picture shows the grain structure just after cold work. So it is the grain structure that I was showing to you like this. After cold working, elongated structures, those I was showing to you. These grains are like these grains. So we'll start from here, just after the cold working. So just after cold working, grain size is like this. So you can see something is happening here inside these elongated grains. Some different small grains are taking place. So this point is known as recovery. So recovery just started here. So recovery just started here, and now this is the recovery phase, where you can see the original grains are being recovered, and here they recovered completely. So this is known as recrystallization. Recrystallization means getting the or crystallized structure back. Now what happens here, these crystals, like these crystals will become like this, and these crystals will become like this. So their growth will take place, and that's known as grain growth. So these are the all four stages: recovery, then recrystallization, and grain growth. Now here are some small terms like warm forming. It is the forming process between cold working and hot working. So if the temperature is nearby recrystallization temperature, then that can be termed as warm forming. So deformation produced at temperature intermediate to hot and cold forming is known as warm forming. Compared to the cold forming, it reduces load, increases the material ductility, and compared to hot forming, it produces less scaling, and so decarburization and better dimensional precision can be occurred. So the point here is, like, whatever the advantages we are having in cold forming and whatever the advantages we are having in hot forming, the combination of all these we can achieve nearby the recrystallization temperature. So the name given to that point is known as warm forming, or you can say warm forming range. So it is the range nearby recrystallization temperature. Now isothermal forming is the forming at isothermal temperature, because as we can see during the heating process, there might be some surfaces those are not properly heated or they are cold. So there is a potential difference between the cold surface and the hot surface, which may result in uh, ununiform distortion or deformation. So for temperature sensitive materials, deformation is not uniform. So in that case we will go for the isothermal forming. So isothermal forming means the surface temperature of the all the surfaces will be at same temperature. All the surfaces will be at the same temperature, and that will be do for particularly the material those are temperature sensitive. So let's start the uh, different questions, previous year questions based on our understanding that we have seen in the last two lectures and in this lecture. So let me recapitulate what we have studied. We have seen basically we have seen three things, that is cold working, hot working, and recrystallization temperature. So what is recrystallization temperature? It is the temperature which defines whether the process is hot working or cold working. What is cold working? If the temperature is below recrystallization temperature, then that process is known as cold working. What are the different advantages of the cold working? In cold working, we will get better tolerance or better dimension or better surface finish. And what are the other advantages? So let's go to the, I also do not remember all the advantages. So let's go to the cold forming. So here are all the advantages: better tolerance, better surface finish, strain hardening increases. Yeah, so another advantages is that we will get the increased strength of the material, and no heating of the workpiece is required. And another advantage is grain flow during the deformation can cause the desirable directional properties. So let me point out all these important points. So first one is good dimensional tolerance. Second point, better surface finish. Third point, strength and hardness, good strength and hardness. Fourth point, directional properties. And fifth point, no heating required. Okay, now come to the disadvantage. In disadvantage, higher force is required. Surface, that initial surface that we have taken, that must be free from scale and dirt. Ductility will decrease. That's the disadvantage that we are having. Metal must be annealed. Annealing is required just after the cold working process. So these are some disadvantages. Now in case of hot working, let's see the advantage. What are the advantages? One advantage is less power machines are required. Another advantage is porosity is removed. So remember, this is again important point. So porosity is eliminated. Grain structure is refined. And impurities are removed or distributed throughout. And mechanical properties such as toughness and other mechanical properties are also improved. Now come to the disadvantages. The advantages that those we are having in the cold working process, those all advantages are disadvantages here. Like we do not have close tolerance, we require expensive tools, we do not have good surface finish. Okay, so these are some disadvantages. Now come to the questions. So I believe that after these three lectures you will be able to answer at least some of the questions. So my dear students, let us see one by one. First statement is that lead, zinc and tin are always hot worked. So what is your opinion? Because as I have mentioned, for lead, zinc and tin, recrystallization temperature is room temperature or below that. So we can term the working as a hot working. Now what is the reason? If they are worked in cold state, they cannot retain their mechanical properties. That statement is also true because he is talking about mechanical properties, and we have seen that if you go for the cold working, then mechanical properties like hardness, strength, ductility, they all will change. Either increase, ductility will decrease. So this statement is also correct, but they do not have any relation between uh, them. Now come for the next question. Cold working of steel is defined as, so cold working is below recrystallization temperature. Hot rolling of mild steel. So hot rolling of mild steel is, for steel, recrystallization temperature will be about 600 degrees centigrade. So generally we have seen in the slides that it is about 1000 degree centigrade. So there is not any option regarding to 1000 degree centigrade. So we can answer the, what we can answer, above recrystallization temperature. So this is the answer. Now material after the cold working are subjected to following process to relieve stresses. That's the very important point, because this process is not at all necessary. Remember my dear students, materials after cold working, it's not necessary that they will go for another process that's known as annealing. So annealing is required for more cold working. It's not always necessary, but he has mentioned here that for relieving stresses. Now we can answer that it's a annealing process. Now which one of the following is the process to refine the grain of metal after it has been distorted by the hammering or cold working? So once the grains distorted, by which process we can gain that structure back? So what's that process? That process is known as, let me write here, recovery followed by recrystallization followed by grain growth. Okay, so combination of all these three is known as annealing. Now in the next question, consider the following statement in comparison to hot working and cold working. So he's asking for the cold working. Higher forces are required. That's true or not? So higher forces are required. That's true. No heating is required. That's also true. Less ductility is required. No, that's not true. Why less ductility is required? If ductility is good, that's better for us. So this statement is not true. Better surface finish is obtained. That's true. So answer is 1, 2 and 4. If you can find, yes. So B is the correct answer. Now come to the next question. Consider the following characteristics. So let me read the statement. Which of the above characteristics of hot working are correct? So in regarding hot working, he is asking to find the correct statements. So porosity in the metal is largely eliminated. That's correct. Strength is decreased. That is not correct. So strength also increased, or we can say strength increased slightly. That's the more better option we can write over here, but it does not decreased. Now close tolerance cannot be maintained. Yeah, that's true, because in cold working we can maintain the close tolerance, but in hot working it's not possible. So answer is 1 and 3. So D is the correct answer. Now in the next question, consider the following statements. Which of the statement given above are correct? So find the correct statements. Metal forming decreases harmful effects of impurities and improve the mechanical strength. That's very true. Metal working process is a plastic, obviously, plastic deformation. Very intricate surface shape, very intricate shapes. Intricates in the sense like, too much complicated shape, where some internal holes are there and bending is there, conical shape is there, then again internal hole is there, and like this means somewhat complicated. So very intricate shape can be produced by forging process. No, no, no. As compared to casting process, no, no, no. Yeah, in casting actually we can produce intricate shapes. We have getting system and molten metal is poured, and then there it is possible, but in forging it's not possible. So this statement is wrong. So answer is 1 and 2. 1 and 2 only. Now the next question is, cold forging results in improved quality due to which of the following? So find the correct statement here. So better mechanical properties of the process, yes. Unbroken grain flow, yeah. Now here you might get confused. So my dear, two words are there. One is distorted. So grain always gets distorted, but here he is talking about unbroken. So that's very true, because in case of cold forming, grains are like this. Grains are like this. So they are unbroken. So this is very true. And one of the biggest strength of the cold working is this one only, unbroken grain flow. Smoother finish, yeah, that's true. High pressure. So high pressure, this is now we have to go to the options, because this also seems true, because high force means high pressure, but in option 1 2 3 4 is not there. So we can answer 1 2 and 3. Now next question, cold working of metal results in increase of strength and hardness. What is your opinion? Is this true or not? True. Okay, true. Cold working reduces the total number of dislocations per unit volume of the material. Yeah, now I also have to think about this option. Cold working reduces the total number of dislocations per unit volume. Yeah, that's true, but what's the relation between 1 and 2? Actually, this statement is true, as I have mentioned, both hot working and cold working. Both will reduce the dislocation, that is this one, the gap between the grains. So they will reduce this one, because elongated grains will be there. So statement A and B, or assertion and reason, both are true. But is there any relation between assertion and reason? That's the point here. So dislocations removed, and because of this only we get the increased strength. Actually the reason is, if we remove the dislocations, then the area of the grains, surface area of the grains will increase. That will increase the energy, and that will finally results into the strength. So here answer is A. So let's come to the next question. Cold working produces the following effect. So stresses are set up in the metal, grain structure gets distorted, strength and hardness of the metal are decreased. So इसको तो हटाओ, सरफेस फिनिश रिड्यूस्ड, इसको भी हटाओ. सो एक ऑप्शन तो कुछ दिख नहीं रहा, तो आंसर इज 1 and 2. Sometimes we can jugaad also we can use that, many times that works. As a if you're writing competition, means you must be good into jugaads. Anyway, these questions sorry, questions are not only for competition. These questions will help you to write your semester exams also. Now come to this question. To obtain the large deformation by cold working, intermediate annealing is not required. Wow, what a statement. So this statement is complete joke. So this is wrong, because annealing is required. Now if this statement is wrong, I think we should not move to the reason, directly we can answer the D as an option because A is false. Then R must be true, but we can read cold working is performed below the recrystallization temperature. That's very true. In the metal forming process, the stresses encountered are greater than, yeah, that's the point I already explained in the lectures, previous lectures. So where we will be doing our, the forming in which range, if you see on the stress strain diagram of the steel, then as I have mentioned, in this particular range we will be, this range. So in this range we will be doing the forming process. So what is that range? That range is between the yield strength and ultimate strength. So option A is correct. Now in metals subjected to cold working, strain hardening effects is due to. So in metals subjected to cold working, strain hardening will be there. That's due to which one of the following? That is slip mechanism, tuning mechanism, dislocation mechanism, and fracture mechanism. So the strain hardening will be because of the dislocation mechanism. So these are some questions that I have taken from ES and GATE exam. And now actually the length of the video is, oh my god, too much. So I have to conclude here. Dear all, thank you so much for this your valuable time. Have a good day. Thank you. And now we will meet in the next lecture, that will be on the forging process. So forging, rolling, and extrusion and drawing process we have to see. So next lecture will be either on the forging or rolling process. Have a good day. Thank you.